Okay, so once again, good morning. So this time our topic is about web services, no? So, oh my God. Again, web services, of course, is a piece of, is any piece of software that makes list available over the internet and uses a standardized XML, no, messaging system, no. XML is used to encode all communications to a web service, no. Let's say, for example, a client invokes a web service by sending an XML message, then waits for a corresponding XML response. Now, as all communication is in XML, web services are not tied to any one operating system or programming language. Actually, Java can talk with Perl. Windows application can talk with Unix application. The web services are self-contained, no, modular, distributed, dynamic applications that can be described, published, located, or invoke over the network to create products, processes, and supply chain. And these applications can be local, no, distributed, or web-based. So web services are built on top of open standards such as TCP/IP, HTTPS, no, Java, HTML, and XML. Again, the web services are XML-based, no, information exchange system that use the internet for direct application to application interaction. And this system can include programs, objects, messages, or documents. Web server service is a collection of open protocols and standard used to exchanging data between applications or systems. So software application written in various programming languages, because of course we had PHP, no, we are allowed to use also C#, Java, Visual, no, and so on and so forth. And running on various platforms can use web services to exchange data over computer networks like the internet in a manner similar to inter-process communication on a single computer. So this interoperability, no, between of course Java and Python or Windows and Linux application is due to the use of open standards. Okay. So to give us more details about the topic, let us all welcome our presenter.
Good morning, everyone. Today, I'm going to discuss our Lesson 8 Web Services for Advanced System Design and Implementation. In this discussion, here are the learning outcomes. Define what is web services and its functionalities, characteristics of web services, components of web services, how does a web service work, what are the different types of web services, and the role of HTTP and on web services and web services versus API. So, what is web services? A web service is any piece of software that makes itself available over the internet and uses a standard XML messaging system. XML is used to encode all communications to a web service. It is a self-contained, modular, distributed, dynamic application that can be described, published, located, or invoked over the network to create products, processes, and supply chains. Web services are XML-based information exchange system that use the internet for direct application-to-application interaction. This system can include programs, objects, message, or documents. It is also a collection of open protocols and standards used for exchanging data between application or systems. Web service are XML-based information systems that use the internet for direct application-to-application interaction. These systems can include programs, objects, message, or documents. It is also a collection of open protocols and standards used for exchanging data between applications. Here are the examples of XML-based. It is similar to HTML, but without predefined tags to use. Instead, we are using our own tags. Here are the examples. Here is an employee data with their employee ID and their data, first name, last name, hire date, department code, and salary. We also have another format, which is the JSON. JSON stands for JavaScript Object Notation. It is a lightweight data interchange format in plain text written in JavaScript Object Notation. What are the characteristics of web services? Web services use XML at data representation and data transportation layers. Using XML eliminates any networking, operating system, or platform binding. Web service-based applications are highly interoperable at their core level. Remember in our OSI layer, we have our representation and transportation. So doon dumadaan yung ating web services. A consumer of a web service is not tied to that web service directly. The web service interface can change over time without compromising the client's ability to interact with the service. A tightly coupled system implies that the client and server logic are closely tied to one another, implying that if one interface changes, the other must be updated. It has the ability to be synchronous or asynchronous. Synchronicity refers to the binding of the client to the execution of the service. In synchronous invocations, the client blocks and waits for the service to complete its operation before continuing. Asynchronous operations allow the client to invoke a service and then execute other functions. Web service supports remote procedure calls. Web service allow clients to invoke procedures, functions, and methods on remote objects using an XML-based protocol. Remote procedures expose input and output parameters that the web service must support. Web service also supports document exchange. One of the key advantages of XML is its generic way of representing not only data, but also complex documents. These documents can be simple as representing a current address, or they can be as complex as presenting an entire book or request for quotation. Web service support the transparent exchange of documents to facilitate business integration. What are the components of web services? Service provider or publisher. This is the provider of the web services or our server. The service provider implements the service and makes it available on the internet or intranet. The service requester or our client. This is the consumer of the web service. The requester utilizes an existing web service by opening a network connection and sending an XML request. So how does the web service work? A key feature of web services is that applications can be written in various languages and are able to communicate by exchanging data with one another via web service between clients and servers. A client summons a web service by sending requests via XML, and the service then responds with an XML response. So either sa server, iba yung gamit nilang programming language, either Java, C#, C++, magsisend lang siya ng XML data papunta sa clients, and then yung clients either ibang language din yung gamit, isa-send back yung data with an XML format. What are the different types of web services? XML-RPC, or the remote procedure call, is the most basic XML protocol to exchange data between a wide varieties of devices on a network. It uses HTTP to quickly and easily transfer data and communication, other information from client to server. We have our UDDI, or the Universal Description, Discovery, and Integration. This is an XML-based standard for detailing, publishing, and discovering web services. It's basically an internet registry for business around the world. The goal is to streamline digital transaction in e-commerce among company systems. We have our SOAP, an XML-based service protocol to exchange data and documents over HTTP or SMTP, or our email, Simple Mail Transfer Protocol. It allows independent process operating on these disparate systems to communicate using XML. Last, we have our REST, provides communication and connectivity between devices and the internet for API-based tasks. Most RESTful services use HTTP as the supporting protocol. What is the role of HTTP on web services? The Hypertext Transfer Protocol is the most often associated with the World Wide Web. This is one of the transfer protocols in use on the internet. HTTP is by far the most used transfer protocol for web services, and it plays a crucial role in REST. The HTTP specification describes messages that represent requests from a client to a server and response from a server to a client. A message from a client to a server indicates a method, either an action or your get, put, post, and delete that is desired for a specific resource designed by a URI. URI are simply formatted strings which identify by name, location, or some other characteristic. Web services versus API. API can be hosted within an app or ISS, or the Internet Information Services by Microsoft, but a web service can only be hosted on ISS. Web services are not open source and are used to understand JSON or XML, whereas APIs are open source and only use XML. API is a lightweight architecture, but limited bandwidth devices such as smartphone. Web services are not lightweight architectures since they require SOAP to send and receive network data. APIs can use any form of communication, but a web service can only use SOAP, REST, and XML RPC. APIs support URL request response, headers, caching, versioning, content formats, but web services only support HTTP. However, there are also similarities between API and web services. Both are accessed through HTTP, HTTPS to enable communication between service providers and customers. Both call a function, process data, and receive a response. And that's all for my presentation. Thank you. And if you have any question, you may ask. Hello.
Okay, so thank you very much, sir, no, for your presentation. So a while ago, no, our presenter mentioned about the components of web services, no. So the basic web services platform is XML plus HTTP, no. But of course, we look into the HTTPS, no, the Hyper Text Transfer Protocol Secure, no. So all the standard web services work using the following components, no, yung SOAP, no, yung simple object access protocol, no, yung SOAP, no. UDDI, no, Universal Description, Discovery and Integration. We have also WSDL, no, Web Services Description, of course, language. And all these components have been discussed in the web service architecture chapter, no. So how does a web service work, no? Or a web service enables communication among various applications by using open standards such as HTML, XML, WSDL, and SOAP. Okay, so XML, to tag the data, SOAP to transfer a message, and WSDL to describe the availability of service. So you can build actually Java-based web service on Solaris that is accessible from your basic Visual Basic program that runs on Windows. So you can also use C# to build new web services on Windows that can be invoked from your web application that is based on Java Server package, no, or pages, no, JSP, and runs on Linux. Okay, so let's say for example, no, if we create or if we can consider a simple account management and order processing system, so the accounting personnel use a client application built in, let's say, in Visual Basic or GSP to create new accounts and enter new customer orders. No? So the processing logic for this system is written in Java and resides on a Solaris machines. So which also interacts with a database to store information. So of course, the step, of course, to perform this operation, number one, the client program bundles the account registration information into a SOAP messages. Then number two, the SOAP message is sent to the web service as the body of an HTTP post request. Then the web service unpacks the SOAP request and converts it into a command that the application can understand. And the application processes the information as required and respond with a unique or new unique account number of that customer. So next will be the web service packages the response into another SOAP message which it sends back, no, to the client program in response to its HTTP request. So the client program unpacks the SOAP messages to obtain the result of the account, no, registration process. So in exposing the existing functions on the network, a web service is a unit of managed code that can be remotely invoked using HTTP. So that is, it can be activated using HTTP requests. No? So web service or web services allow you to expose the functionality of your existing code over the network. So once it is exposed on the network, other applications can use the functionality of your program. Actually, when it comes to interoperability, web services allow various applications to talk to each other and share data and services among themselves. Other applications, now let's say, it can also use the web services. Now, let's say, for example, a BB or .NET application can talk to Java web services and vice versa. So web services are used to make the application platform and technology independent. Now, how will we be able to standardize the protocol? Web services are standardized industry standard protocol for the communication because all the 4 layers, now take note of it, in the standardized protocol of web services, we have the 4 layers. That is service or service transport, XML messaging, service description, and service discovery layers. It will define protocols in the web services protocol stack. No? So the standardization of protocol stack gives the business many advantages such as a wide range of choices, reduction in the costs, no? Due to competition, of course, reduction in the cost due to competition, and increase in the quality. When it comes to the low-cost communication, web services use SOAP over HTTP protocol. Why? Because you can use your existing low-cost internet for implementing web services. And this solution is much less costly compared to proprietary solutions like ADI B2B, no, besides SOAP over HTTP. Web services can also be implemented on the reliable transport mechanism like file transfer protocol. So there are some actually web services special behavioral characteristics. Number one, of course, the most commonly used, the XML base. No? Web services use XML at data representation and data transportation layers. Using XML, no, eliminates any networking, operating system, or even platform binding, because web services-based applications are highly interoperable at their core level. I think you're also familiar with loosely coupled. No? A consumer of a web service is not tied to that web service directly. So the web service interface can change over time without compromising the client's ability to interact with the service. No? So a tightly coupled system implies that the client and server logic are closely tied to one another, implying that if one interface changes, the other must be updated. Adopting a loosely coupled architecture tends to make software, no, of course, system more manageable, and it allows simpler integration between different systems. Now, how about, I don't know if you're also familiar with coarse grain, no? Coarse grain, of course, is an object-oriented technology such as Java expose their services through individual methods. No? So, an individual method is to find an operation to provide any useful capability at a corporate level, because building a Java program from scratch requires the creation of several fine-grained methods that are then composed into a coarse-grained services that is consumed by either a client or another service. Because businesses and the interfaces that they expose should be coarse-grained, and web services technology provides a natural way of defining coarse-grained services that access the right amount of business logic. Now, in web services, we need also to consider the synchronous and asynchronous. Now, synchronicity refers to the binding of the client to the execution of the service. So in synchronous invocations, the client blocks and waits for the service to complete its operation before continuing, because asynchronous operations, on the other hand, allow a client to invoke a service and then execute other functions. Asynchronous clients retrieve the results at a later point in time, while synchronous clients receive the result when the service has completed, because asynchronous capability is a key factor in enabling loosely coupled system. So we have also support remote procedure calls, yung RPCs na tinatawag natin. Web services allow clients to invoke procedures, functions, and methods on remote object using our XML-based protocol. So remote procedures expose input and output of parameters that a web service must support. So component development through enterprise Java beans, yung AJBs natin, and even .NET components has increasingly become a part of architecture and enterprise deployments over the past couple of years. Both technologies are distributed and accessible through a variety of RPC mechanism. No? Okay, so a web service supports RPC by providing services of its own, because equivalent to those of a traditional component, or by translating incoming invocations into an invocation of an AGB, no, yung Enterprise Java Beans, or even the .NET Framework component. Now, one of the key advantage of XML is its genetic way of representing not only data but also complex documents. And these documents can be as simple as representing a current address, or they can be as complex as representing an entire book or requests for quotation. No? Web services support the transparent exchange of documents to facilitate, of course, the business integration. That is too important. Ano? Okay, so I think that's it. Actually, web services architecture actually is, I think, another topic, no? But this will be a part of web services rules. Of course, going to discuss, of course, the service providers, the server requestors, the service registry, and of course, the web service protocol stack. Okay, so I think somebody was assigned to discuss that topic, no? So it's under web service and software architectures. Okay, so I think that's it for this topic. Thank you, sir. Okay, may I request everyone yung pwede mag-turn on ng camera for our attendance for today. So, before I forget, so next meeting, our topic is about implementing the model-driven architecture by Palo. Then, case study of web system design, development, kay Sir Pantaleon ulit. Thank you, sir. Catalog of model transmission, kay Season. Then software architecture, Suleta. Then IoT, IR 5.0, that is Canicosa. Then software development security kay Espaldon. Cyber security, Laksamana. Then risk management ng system development, system design and implementation, Santiago. Okay? So, sige, picture na po si Doc. Wait lang. O, kunti lang pumapasok sa atin, ha? Okay, so 1, 2, 3. Ayun. Okay po, salamat po sa pag-attend ng class. Good luck sa next subject po ninyo. I think you have still time naman pa para maka-break pass muna bago yung next subject ninyo. Ingat po lahat. Bye-bye. Okay.
Thank you, Doc.
Okay. Huwag kalimutan yung mga requirements, mga sirs at ma'am, ha? Huwag kalimutan mga requirements natin. Malapit na mag-end ang SEM.
Sir, may tanong po pala.
Okay.
Sir, may format po ba yung documentation ng system?
More on anak? Ay more on parang gumagawa ka lang, sir, ng introduction lang, user's manual. Siyempre may introduction mo yon. Tapos parang user's manual and developer's manual ang gagawin niyo dyan. Same with software engineering, documentation lang. More on technicality lang, hindi siya more on na parang katulad ng may analysis, hindi na po ganon. Okay?
Yes, sir.
Open tayo sa format kasi depende po yun sa inyong proposal. Let's say kung halimbawa more on DSS siya or expert system, syempre iba yung content ng documentation nun. Pero kung more on technical po tayo, iba rin yung documentation nun. Kaya open po tayo. But ang pinaka-guide na pwede ko ibigay sa inyo, almost the same sa documentation ng software engineering output. Okay?
Okay po.
Okay, maraming salamat po and good morning. Okay. Salamat. Stay safe everyone.